Welcome to this video on how to write your results section of your lab report. Your objectives are to 1. Explain what evidence must be presented in the results section of the lab report, and 2. I'm going to show you how to create a graph using Excel. I'm only going to show you how to do a line graph and a bar graph, so if you want to see any other types of graphs then come and see me if you're unsure on how to produce them. The results section itself is a fairly short section. It's not particularly difficult to do because all you're going to do in this section is put your graphs in, okay, give them a title and describe what the graphs are showing. At this point you don't need to do any data comparison, so look at normative values. You don't need to explain the phenomena or what you're finding in your results. You are literally just putting your results in and saying what you have found. No explanations and no comparisons between any of the research projects or normative values. You do have to present your data in a standard format, and the format is at the bottom of this slide. Average plus or minus standard deviation versus average plus or minus standard deviation of units and the p-value. Okay, so what does that look like in an actual paragraph? When you're talking about your results, either underneath your graph or in a paragraph underneath your graph, then this is how they need to be represented. Okay, so the heart rate results revealed that at 4 minutes, heart rate was significantly higher in the caffeine group when compared to the non-caffeine group. That sentence is describing what you found within your study. In the brackets underneath in the green, you can see that standard format, the average 134.2 plus or minus the standard deviation 4.5 versus 125.4 as the average plus or minus 5.6 standard deviation. BPM, beats per minute, is the unit, and then the p-value that they've got from their statistics test. The results are put in order respectively for the brackets. Okay, so if we read that sentence again, the caffeine group when compared to non-caffeine group, the caffeine group's results is 134.2 plus or minus 4.5, and the non-caffeine group results are 125.4 plus or minus 5.6 beats per minute. Okay, so that's how you need to represent them within your lab report. Now what does that look like? I have got an example for you to look at. Okay, so this is an example of a results section that got a distinction in a couple of years ago. So you can see straight away a really colourful graph which has represented on their standard deviations as the error bars you can see here from each point. Okay, you can see it's Lucozade versus Aldehyde, or whatever the Aldehyde sports drink is called. Okay, on the graph, this graph represents its heart rate over time. Okay, and what the person has done is they have described the results below. Okay, so graph 1 shows at the end of the test an average Lucozade had the lowest overall heart rate. So that's a good starting sentence to describe what is happening within the graph. They then go on underneath to talk about the exact numbers. Okay, so here you can see the standard formatting I was talking about just a second ago with a p-value included. Okay, so this is exactly how I want to see your results set out within your results section. There's a few graphs in there. Okay, so depending on what the factors you have found or the factors that you're going to discuss within your results will depend on your graphs. Okay, you can do your graphs any way you want as long as they represent your results nicely. Okay, the most important bit is you describing them correctly and getting in the standard formatting of representing your numbers. Okay, these graphs could be improved a little bit, but I'm going to show you how to do a really good graph in just a second. But overall, have a read of what they've wrote about each graph, take a look at how they represented their figures, okay, and take some notes on that because this is a really good piece of work and it's a really good results section. Okay, so I expect to see yours just like that. Right, let's move on to how to actually produce a graph. Okay, so your second objective. Now what you can see here is I have a set of data. I've got heart rate data, Lucozade versus water. So the first thing we have to do, I haven't put my participants in, so let's just, for argument's sake, so that's participant 1, that's number 2, and the same for the second group. Okay, so 2 participants in each group for Lucozade and water. So the first thing I need to do is calculate the average for each time point. At the top you can see time in minutes, which is time 1 to 10, so 10 minutes worth of exercise. To do this, the easiest way to work out your average is to type into Excel equals average, open your brackets, highlight your 2 data points and push enter. Once we've done that, we can take this little black box at the bottom of the corner and drag it across all time points, and you have your averages. The next thing we need to do is your standard deviations, so that's STDEV, get it right. Open your brackets again, highlight the same data points, you do not highlight the average, push enter, and the same process applies, just drag that box across. I like to highlight my data so that I know exactly which is my standard deviations and averages, so I don't get confused between them and the normal data. And you need to do the same for the second group. Okay, so the averages, as we've discussed in class and in your first year, allow us to generalize data between groups. They allow us to look at different people, different conditions, etc., etc. Okay, if you're not sure what that, look back over your notes. Your standard deviation is basically telling us how far away from the average the results are. They're basically telling us the lower the standard deviation, the more accurate our mean is representing the group. Okay, so the higher the standard deviation, then the less accurate the average is when representing the group. So this one here is quite high. Okay, but we know how to deal with them from previous lessons, so I will move on. So again, highlight them up. Right, to do a really good line graph, okay, which represents all your data points and your standard deviation as error bars, okay, you need to first of all go to insert, okay, line graph, and just select 2D line graph in the top. You should get this blank box up, right click, select data. Okay, in this box we need to go to legend entries and click add. Okay, so my series name, I'm going to put in my averages for Lucozade first. So in there I will type Lucozade, and in the series values box I will delete everything in there first of all. Go to your data and highlight all of the averages. Okay, click OK, and if we just move this box over, you should see your first line on your graph. Okay, so that's going well so far. You need to now add in the water. So again, series name water, delete what's in the series values box, and again highlight your data, average heart rate data. Click OK, and again we can just have a quick check and make sure both lines are on there, which they are. Okay, if we wanted to edit the bottom axis, we can click edit here, and if you wanted to, if it was different, I mean, it doesn't matter because it was 1 to 10 anyways, but we can highlight 1 to 10 for time and minutes, and that should appear at the bottom of the graph. Click OK, and we have got our results onto a graph. Now there's a couple of things that make it look much better, and at university you will be expected to print off your work. Therefore, if you were to do your graphs in colour, then when you print them off, all the lines will look identical. So the best thing to do is just to do your graphs in black and white or grey and black. You can add in fancy lines if you want. It's entirely up to you, as long as they are neutral colours which can be shown on printed out work. Obviously coloured lines will just appear black on printed out work. The next thing we want to do, I've deleted the lines in the background and I've used the design to change the colours. Next thing we're going to want to do is give the graph some titles. So if you go to layout, across to axis titles, we'll do the primary horizontal axis first and click on title below axis. You'll get your label underneath. Obviously our bottom axis is time in minutes. Make sure your units go in the brackets, please. Do not submit any graphs without the axes labeled with the units. Okay, so time minutes for the bottom. Go back to axis titles, primary vertical axis title, rotated title because it looks neater. Okay, and on here we obviously have heart rate. Okay, in there BPM, beats per minute. Okay, make sure you've got units in. Okay, so we're looking pretty good for now. It's quite clear. What we can start to do is, obviously we're not going to have a heart rate from 0 because we wouldn't be alive, so we can change the axis to make this a little bit better, make the results a little bit clearer and bigger. So if you click on your axis title there and right click, we can see here we don't have a heart rate lower than 60, so I'm going to use 60 as my starting value. So we're going to right click on the label, or the axis labels, format axis at the bottom, and go to axis options, minimum, and change it to fixed, and within there we can write in 60. Click OK or enter, and you can see that my bar now starts from 60 beats a minute and my results look a little bit nicer. Alright, personal preference here with where you put your key. You can leave your key there if you want, but I personally think it looks neater on the graph, and we can make the graph bigger then, which again, you know, that's the whole reason we're doing the graphs for, to make the results look nice and big. So I can move my key in. You don't have to do that, that's entirely up to you. Okay, at this point we've got a graph, we've got a line graph, which is showing the average heart rates. However, we haven't got standard deviations on yet, so to do that we are going to click on a line. I will start with the water, that's the top line, so click on the line for me and go to error bars at the top. Click on error bars and go down to more error bar options. When you're in more error bar options, you have a couple of different choices to make. If you want your line graph to have the standard error bars on both the top and bottom, okay, which looks nicer, but sometimes the lines are too close together, then the error bars impede each other. So sometimes it's better to the top line having the top error bars on the top and the bottom line to have the error bars on the bottom. We're going to go with just both, so I've left that as both there. Okay, but we'll see how it looks once we've done it, and if it doesn't look very good, then we'll change it. So I'm going to go with my vertical error bars on both up and down. So I've selected both there, and we're going to go down to custom value. Okay, so click on custom value and then go to specify value. Now in the positive error value, I'm going to highlight my data, although I can't see my data, so I'm hoping that's correct. And then again, oops, we're going to delete all that. Okay, and we're going to highlight standard deviations again. I think that it worked. Okay, so click OK on that and close, and you can see my standard deviations are now, or our error bars are now represented by standard deviations up and down the graph. Okay, so we can see at time points 5 to time point 8 there are some quite big standard deviations in the heart rates. Okay, we've got to do that again for the bottom line, and we will see if the error bars impede each other. So leave that at both, go to custom value, specify value, and again we're going to put in the standard deviations for Lucozade this time. So 910, again on your negative bar, do 910 again. Okay, so not so bad. Okay, it looks quite neat. Okay, so that is how to do a line graph in Excel. The only other thing I would stress is to take away format chart area, take away the border, because when you copy and paste it over into Word, as you can see on this example here, the borders look a bit naff, in my own opinion. So if you take them away, the graph looks neater, it looks like it fits into Word much better. Okay, so that's how to do a line graph, and the rest of the video was how to do your results section. Okay, so a quick review of the objectives. Alright, we have looked at what you need to evidence, your graphs and your descriptions, and how to write in your results. And finally, we've looked at how to create a line graph. Okay, I've run out of time in this video, so I will do the bar graph in another video for you.